Have you ever wanted to know if you can Falcon punch someone onto the moon? No? We're gonna find out anyway. Short answer to this is no, and the long answer is yes and no, but with an added explanation. So let's get into it. You see, when Captain Falcon does his Falcon punch, he generates so much speed and power that it creates fire around him. With this idea, we can get a general idea of how fast he's going. According to an article by Science Focus, you'd have to be running about Mach 5 speed, which is 6,000 kilometers an hour. Now that we know how fast he's moving for the punch, we need to calculate how much power he generates for that punch. The equation we're going to be using for this is force equals mass times acceleration, with the average mass of an arm being 4.97 kilograms. Going to be rounding it up to 5 for the sake of making it easier. The acceleration being about 6,000 kilometers an hour, and the force comes out to around 30,000 newtons. Since we know that the moon is approximately 384,472 kilometers away, we can determine the time it takes to get there by using the equation time equals distance divided by velocity. And with this equation, I can conclude that you will be traveling in the air for about 64 seconds before you reach the moon. But there is one thing about this that I didn't take into consideration: air resistance. Now, I would calculate air resistance, and trust me, I've tried, but I kind of can't. I can't really seem how to calculate it, because it's too complicated, alright? But the least I can do is explain what air resistance is. You see, air resistance is basically the same amount of force being pushed onto that object in the opposite direction it's traveling, which can be represented by this picture. Okay, so here's the fun part. We're actually going to find out what'll happen to you and the person being punched if you actually manage to Falcon punch someone onto the moon. So, let's see what happened. According to an article by science.ca, the human can withstand 50 psi as long as it's like a sudden impact. And in order to find out how much psi the Falcon punch exerts, we just need to convert to 30,000 newtons to psi using a simple newton to psi conversion calculator. Because, when given the chance to take the short route and be easy, why wouldn't I? So, knowing this, the Falcon punch exerts about 4,351,132 psi. Yeah, so it's safe to assume that the human body would explode from that punch. Now, let's just say, for the fun of it, that the body doesn't die and stays intact from the punch. Once you get to space, you'd only survive without a suit for about 10 to 15 seconds because, the vacuum of space will suck out all the oxygen from your lungs and rip all of your intestinal organs and all that nasty junk. Now, with the amount of speed that you'll be punching the person, the heat of the flame will be approximately 1,500 degrees Celsius, or 2,732 degrees Fahrenheit. And according to AccurateBuilding.com, most adults will suffer third-degree burns if exposed to 150-degree water for 2 seconds. Burns will also occur with a 6-second exposure to 140-degree water, or with a 30-second exposure to 130-degree water. Even if the temperature is 120 degrees, a 5-minute exposure results in third-degree burns. Now, I know this is talking about boiling water being burned on you, but whatever, I don't think it matters that much, since either way you're going to be burned to a crisp. Because if these temperatures give you third-degree burns, then a 1,500 degrees Celsius burn or 2,732 degrees Fahrenheit burn will burn your hand to a crisp, possibly even your whole arm to a crisp. This certainly was an interesting video, and kind of fun to make, to be honest. Now, I did do these equations and the research myself, but I do have to credit my teammates for this, because in the very beginning, they did help kickstart this by finding out steps to do, the equations to use. All I really did was just fill in the numbers. So in other words, they walked so I could run. Also, don't expect these calculations to be perfect, because they probably aren't. What really matters is that I managed to do this in the first place. And if you want to see more of these, just say so, because these are fun to make, and I can imagine they're also fun to watch.